Hey everybody. Let's go ahead and get started. To start us off today, I actually have a very cool announcement. Remember back in the first week, we asked you guys to think of a team name. We also asked you guys to draw up a team logo, and most groups actually did that. Tiana here, who is on LaunchCode staff, took those team names and those logos and turned them into the real thing. And when you guys break up into groups later on today, we're going to pass out stickers with your team name and logo on them. Yeah. So you can show off your team pride on your laptop wherever you go now. So they all look fantastic. She did a fantastic job. Yeah.
Who's in Space Pythons? Who's in that group?
Yeah, Space
That's
Pythons.
My favorite. You guys are awesome.
Pythons in space.
That's great.
There's lots of good teams. All right. Variety pack. Ooh. Nerdy nebulas. Yeah.
You guys are very creative with your names.
There we go.
I gotta hand it to you.
So I know I went through those a little quickly, but like I said, your TAs will have stickers that they're going to distribute to you all when you break up into your groups. So can we get a round of applause, actually, for putting those together?
Thanks, Dad.
Yeah. All right. Let's get back to the task at hand. Actually, I didn't mean to go to this tab next, but since I did, I'll go ahead and chat about it a little bit. Initials is a large assignment. And so by large assignment, you know, it means it's going to take you a little bit more time. It's not actually due for a couple of weeks, so you do have some time to work on it. However, I think it's a good idea for you to get started sooner rather than later. You definitely don't want to be sitting there Sunday, the day that it's due, staring at a half-empty program trying to figure out the rest. So what I would really like to suggest, and I'll remind you of this towards the end as well, is so part of the initials, I'm actually not even going to talk about the assignment itself today. I do want to talk to you about the initials assignment at some point in class, but what I would really like for you to think about / do today is after you get the studio finished, pull up the initials assignment, and then the first part actually has you set up some tools on your computer. So you're going to be running Python on your own machine, not just in the textbook anymore. So this is kind of a big step forward. It does require a little bit of setup work, though. And it is possible to run into some problems getting those tools set up. And so I think it's a really good idea for you to do that setup here while you've got your TAs and myself around to help you get unstuck if you fall into any problems while you're trying to install Python on your machine. So after you get Studio done today, I would really recommend that you take a look at doing the using Python locally section of the assignment and just get through as much of that as you can before you leave here today. It actually, if everything goes well, does not take that long. It should take maybe 15 minutes or less if everything works the way it's supposed to. But like I said, it's not unusual for problems to occur. And so I just think it's good for you to have some people to talk to about those problems and help you get them fixed. So I'd highly recommend taking a peek at that today, once you get the studio finished. There is an assignment due on Sunday. I believe it's chapter 9. Is that right? I don't remember, actually. It's on the website. I should just look at the website instead of guessing about things. Load this up. Actually, right before class, Ryan posted the remainder of Unit 1, so everything until the end of the unit. So if you're trying to plan ahead, you can do so. So Chapter 9, yeah, I got it right. Okay, Chapter 9 is due Sunday. You can see initials is not due until about 2 weeks, so you got 2 weeks to do it. But again, I would highly recommend you get started on that sooner rather than later. And then you'll have another big assignment called crypto, which is sort of the final assignment of the unit. So Thursday, March 7th is the last day of the unit, and actually my calendar shows Unit 2 down here. This is not true. The 11th and the 14th, we don't have class, so these dates will get updated eventually. We do not have class on those days. We get a little spring break. You can all go down to Cabo, do whatever it is that people do when they're in Cabo. All right. Any questions about scheduling before we hop into today's topic? Cool. As always, make sure you're keeping up with the Canvas to make sure you're getting everything submitted on time. And don't fret too much if you don't get something submitted on time. You can submit stuff late, so keep at it, keep working at it, and let us know, let your TAs know, let me know what we can do to help you get back on track if you are slipping a little bit behind. All right. Today's topic is a really good one. We're going to talk about strings. So let's just start off. We've been using strings, right? Strings is not something that's brand new to us. We've been using strings almost since the first day of class. But we're diving a lot deeper into strings. And so, just a real quick refresher. First question should be an easy one. What is a string? Text. All right, good. One word answer, perfect. That's all I need. How is a string represented? This is where we start looking at, in a little bit more detail about what a string actually is. What is a string, really? It's a series of characters, maybe a little bit, there's a certain word, a list of characters, yeah. Or a string of characters, that's where the name string comes from, string of characters. But in Python, it's really a list of characters, and that list has a huge impact on how we can use strings and how strings behave in our program. So that's what we're going to talk about for the rest of today. How do you determine the length of a string? If I want to know how long a string is, the len function, L-E-N, is what we can use to tell us the length of a string. All right, cool. If you are given the string basketball, right, how could you access the letter K? What would you do in your code if you wanted to pull the letter K out of this string basketball? You can assume that it's in a variable. Call it X or whatever you want to call it. I'm sorry? You would index it. What would the index be? 3. The index would be 3. Again, we have to remember that we're starting from 0. So B is 0, 1, 2, 3. How else could we get it? There's another way. A for loop? We're going to talk about loops in a second. If I just want to pull out the letter K. Negative. So negative what? 1, 2, 3, 4, 5, 6, 7. Negative 7. This is negative 1 because there's no negative 0, right? Negative 0 is the same as positive 0, which is 0. Right? So we can count backwards from the end as well. How would you get the T? 5? 1. Oh, sorry. See, I screwed up. Won't be the last time. 0, 1, 2, 3, 4, 5. Yes. 5 or negative 1, 2, 3, 4, 5. Negative 5. Perfect. Negative 5. All right. How would I get the word ball? Index 6. So 6 is where the B starts, right? But I don't just want to get this B. I want to get the whole word ball. A colon, yeah. So what's that colon called? A slice. A slice. We can use a slice operation to specify a range of values that we want to pull out of a list. So if I want to get this, I actually can just say 6 colon, and I actually don't need another value after that, right? It's not necessary. If I leave the number off, it's just going to go to the end. But if I wanted to, if I just wanted to pull out BA, what would that look like? 6 colon 7 or 8? 8. Because we go up to, but not including that last number. So you have to go one farther than what you think you need to do. So it'd be 6 colon 8. Gets you those 2 characters. Are there any questions about that? Okay. What does it mean when I use the less than operator with strings? What's that going to do? Checks, I heard a part of that. Sounded right. I just couldn't hear it all. Before or after? So we're talking alphabetical order, kind of, right? What's the catch? What's the catch? Lowercase and capitals are in two categories, right? So if I'm checking just capital letters, it makes sense, alphabetical order. If I'm just checking lowercase letters, it makes sense, right? What if I'm checking lowercase versus an uppercase? Which one is greater? Uppercase is lower than lowercase? That's a weird way of saying it. If you're ever unsure, if you're ever unsure, as I am sometimes, this comes from the fact that we're using what's called ASCII, which is a very old standard to represent these characters. So you can pull up an ASCII table. Let me see if I can zoom in on this a little bit so we can actually see it. You can pull up an ASCII table. It's literally comparing those letters as numbers. Every letter has a number associated. Whoops, what did I do? I must have hit back by mistake. Didn't mean to. Every letter has a number associated with it. So you can see here that the uppercase letters come first. They start with 65. Get out of here. Start with 65, and then the lowercase letters come a little bit later. They start with 97 and count up from there. And so it is quite literally comparing those numerical values when you look at comparing two strings. Does that make sense? Are there any questions about that? So what's interesting is it's not just restricted to letters, right? You'll notice that I've got punctuation on here as well, numbers, spaces, things like that. Right? That's all on here. And so you can compare those values in strings as well, and if you want to, and it'll tell you the ordering of those strings too, if that's something that you're interested in. This is a pretty old standard, but it still survives on today. Actually, what happened, if you're curious, is the new standard, the modern standard, is called Unicode. And what Unicode does, so ASCII only had room for 256 letters, which sounds like a lot, but actually is not when you consider languages like Chinese or non-Roman alphabets that have many different characters than what we're used to seeing in English. So Unicode has a lot more possibilities of letters. It's in the billions, I want to say, of possible things that can be represented. That's also how we can do things like send emojis, right? Those are all specified in the Unicode standard as well. And what Unicode did, just to make life easier for everybody, is it kept these values for the first 256 letters, so that anything that was using ASCII in the past can still treat those letters the same with the modern standard. Little historical lesson for you, I guess. So every time somebody comes out, I don't know who does actually get to say what emojis exist or not. Somebody has that job. Think about that for a second. Whenever they come out and say, we've got new emojis now, right, that you can send to people on your phone, what they're really saying is, okay, we took some numbers from the Unicode standard and we assigned them to be these symbols. And then your phones and your computers then will get that information and make sure that when they see those numbers, that it represents them with those particular symbols. That's what's happening. Cool. Any questions about that? All right. Let me get back to my slides here. What does it mean when we say a string is immutable? What does that mean? You can't change it. Once I've declared a string, that's what it is forever. Which sounds a little inconvenient, perhaps, right? Sometimes we want to change our strings. Sometimes we want to manipulate the values in our strings. How do we do that? We make new strings. We make new strings. We do it all the time. We're going to see some examples of making new strings actually in just a moment when we start doing the walkthrough and in Studio today as well. In fact, I think that's what's next on our agenda. Yeah, it sure is. But before I get there, does anybody have any questions? All right, let's take a look at the walkthrough then. think I've got this set up. Need to zoom in a little bit. Okay. So today's walkthrough has us writing a function called remove char. By the way, I know some people look at this and really want to pronounce it char because that's an actual English word that exists. I regret to inform you that you are wrong. No, you're allowed to boo me. That's fair, but you're still wrong. This is pronounced char because it's short for character. It's not something that has been set on fire, like char. It's short for character. You don't have to agree with me, but I'm not going to talk to you if you don't. So, just warning you. So we're going to write a function called remove char that takes two arguments, a string and a character. The first argument is going to be, or we're going to try to remove all instances of this character from the string. That's the idea. So we're going to go through the string and try to remove all instances of the character from the string. And it ends up being, it's not a very long chunk of code, but there are some important conceptual things to pay attention to as we go through here. So let's start with writing some comments. I always like to start with explaining my thoughts in English and then coming back and turning them into code. So let's start with that. What tools am I going to need to pull this off? We're going to need some kind of a loop. So what are we going to loop over? Loop through what? The string. All right. We're going to loop through the string. And then what are we going to do inside of this loop? Or can we be more specific when I say loop through the string? What am I really looping for? Loop through every letter in the string. Okay, that's a little more specific. All right, what am I going to do inside this loop then? I need some kind of a condition. So if what? If the letter, what am I looking for? Am I going to look for letters that are the characters that I'm trying to remove or letters that aren't the characters that I'm trying to remove? It makes a difference on how we approach this problem.
Or if you're creating a new string, you want to create a new string that has all
the
old string except for.
So that's one idea, right, is to make a new string that contains the letters that aren't the ones that we're trying to remove. Could I do the opposite? Could I try to remove the letters that I want to, just keep the string that I have and take out the letters that I don't want anymore? Because it's immutable, right? I cannot actually change the string that I have, but I can make a new one. I can make a new one. And so that's actually an important piece that we probably should do up here, right? Make a new string to hold our results. Okay? If the letter is not what we want to remove, then we're just going to add it to our results. Right? And then when we get down here to the very end, what do we have to do? Return, yeah, return the result. It's not a very long function. We still have some choices to make, though, and we still have some things that we can discuss, some things that we can chat about as we're coding this up. Let's start at the top, though. We're going to make a new string to hold our result. All right, I'm just going to call it result. It makes sense. What should this be? What should I start this at? Blank. How do I do that? Two quotes. Does it matter? Single quotes, double quotes, does it matter? Doesn't matter as long as they're the same, right? Single quotes, double quotes. Sometimes people will try and do this. That's not an empty string, right? There's a space in there. Feels like it's empty, but that space is actually taking up space. It's actually something that exists, kind of like 0 exists. It's a number to represent the absence of something. Space is sort of the same way, but with strings. All right, so we've got our empty string. And now we're going to loop through every letter in the string. And this is where we actually have an option, right? There's two different ways we could pull this off. What's one way that we could do this? So for loop, yeah, sure, but that still doesn't narrow it down. So we could do for I in string. What's this going to do? This is going to loop through the string. We have a name for it though, right? It's looping by element. It's looping by every element in the list. So I is going to just take on each character one at a time, right? What's the other option? Looping through range. What do we call that? Looping by index. Looping by index. Could I do it that way? Yeah, sure. In fact, I think we will. I think we'll do it both ways just to kind of compare the two methods. But since I typed this one first, we'll stick with it. We'll come back and do it the second way later. All right. If the letter is not what we want to remove, so how do I say that? If I not equals character, then we're going to add it to our results. How do I do this? That word add kind of helps us out, right? Results equals result plus char. I'm sorry, thank you. Result plus I. So it looks like we're literally adding it, right? We're using addition, but that's not what it's called with strings. What's it called? Concatenation. Concatenation is the act of taking two strings and sticking them together, right? Tacking them together. So the first time I go through, let's assume that it's a letter we want to keep. The first time I go through, my string right now is empty. That's what I started it as. And I'm adding that letter to the empty string, so nothing plus the letter is going to be that letter. And as I go through and find more letters that I want, I'll just keep tacking them on the end. Notice that, again, it's important to remember, I think, strings are immutable. Strings are immutable. So every time I do this, every time I run this concatenation operation, I am creating a new string. It is creating a brand new string, right? I'm not modifying any of my existing strings. I'm making new strings every single time through this loop. And then last, but certainly not least, we're just going to return that result. We've got some tests down here that we can use to check to see if things are working properly. They threw a couple tricky ones in here. The first ones are pretty straightforward. Take the A and the K out of aardvark. It tries to remove a letter that's not in here, right? That should still behave the way you would expect. I should just get the same thing back out. And then this one's maybe even trickier still. Remove something from the empty string. Make sure you get the empty string. If I run the empty string through here, how many times is this going to go? How many times will my loop run if I pass in the empty string? Infinite? Oh, I hope not. 1? 0. 0. It'll look at it and say, well, you got nothing. All right, we're done. It'll skip this whole loop and just give you back. It doesn't matter what I put here, right? I can put anything that I want here. It doesn't matter. It's going to look at that empty string, say, well, okay, don't need to run this loop. I'm done. There's nothing to remove. Think about it that way. I'm telling it I want to remove something, but there's nothing to remove. It's empty. So it's just going to skip the whole thing and spit it back out. Well, let's try it. Let's see if these tests actually work. Cool. First try. That's good. But let's do it again. I want to do it a second way. We did it by element the first time. We looped through by element the first time. Let's do it by index this time and see how that's going to change the way that the rest of our code works. So I'm going to comment that loop out. And I'll start another loop. If I want to do it by index, what do I need to say? I in range, and then what? The length of the string. Thank you. That's right. So last time, right, if I passed in aardvark, I was A the first time through, and then it was A the second time through, and then it was R, and then D. This time, I is going to be what the first time through? What's the value of I going to be the first time through the loop? 0. I'm doing it by index this time. So it's going to be 0, and then 1, and then 2, and then 3. And it's going to count up until it gets to the length of this string, reaches the end of the string. So what else do I need to change in my code to take that into account? I'm sorry? I can't quite hear you. I'm sorry. -1 on the length. Oh, let's talk about that. -1 on the length of the string. So if I look at aardvark, right? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 letters in the word aardvark. So if I say for I in range, and now this we know this is going to be an 8 for aardvark, right? How many times is this loop going to run? The way I have it now. It's going to run 8 times, actually. What's the index of the last character? 7. That might seem a little scary, right? This loop's going to run 8 times, but remember, it does not include the last number. We start at 0 and we go up to, but not including the last value. So this will work perfectly. In fact, you might have been wondering, why don't we include that last number? Well, here's the exact reason why we don't include the last number in the range. Because we're counting from 0. It's recognizing the fact that we often are starting from 0. Stopping 1 short for you so that you don't have to type -1 every single time. The -1 is not necessary. That would stop us 1 letter too short. But back to our original question, what do I need to change? What else do I need to change about this code to make it functional? Because I don't think it's going to work right now. The loop looks okay, but I have an error. It even gives us a hint. Cannot concatenate string and int objects. What do I need to change to make this happier? The if statement. All right, what's wrong with the if statement? So we need to use I as an index now. I is a number. This is a character. Can it compare these two things? No. No? Actually, it can. Why? Why is that okay? Because everything in a string is a number, right? But remember, I is going to 0, 1, 2, 3. So even though it can compare those two values, we don't want I to be treated like a letter. If we treated I as 0, we would get these weird things that I don't even really know what they are because I never used them. I don't know what these are. Certainly not what we want in this particular situation. We need to treat I as we treat it in the loop, which is as an index. So to index this, or to treat I as an index, I need to say string of I is how I would say that, or string at I. So the first time through, I is going to be 0. It'll pull out the 0 with the character, and then the first character, and then the second character. Compare them. Are we good? No, what else is wrong? Yeah, this is actually what the error was talking about down here. We can't concatenate strings and ints. So, I mean, your inclination might be, oh, I can't concatenate strings to ints, so I'll just turn this into a string. But hold on a second. That's not right. Again, that's the index. So that's not going to work the way we want it to. We, again, need to treat it like it's an index and pull the letter out of the string that we want. Pull the letter out. And so here you can see, I think this will work now. Let's try it and make sure that it's still functional. Passes. Perfect. Perfect. Okay. Which way is better? The first way we did it or the second way? Does it matter? In this case, the answer is no. It actually doesn't matter. It doesn't matter. The best way is whatever way you feel comfortable with. If you feel comfortable iterating through by element, go for it. If you would rather iterate through by index, that's fine too. There are situations, though, in which it probably would matter. I think there are a few situations in where you would have to choose one way or the other. Like there's just only one way to do it. But there certainly are situations where iterating by index might be more awkward, might be clumsier than iterating by element, iterating by value, and vice versa as well. If I'm trying to find the location of a letter in the string, right? That's actually a situation where I probably have to iterate by index. If I'm trying to find the position of something. Well, have to is a strong word. It would be certainly, I think, a cleaner solution to iterate by index, because otherwise I would have to create my own counter to count up as I go along. Doable, just a little bit more of a roundabout way to get to that solution, as one example. But for the most part, you can do it either way. You can adapt either approach. So pick the one that you're comfortable with. You'll start to see people form preferences for things. This is actually one of my favorite parts about teaching introductory computer science topics, programming topics, is to watch people as they figure out their own style. I have my own style that I use. You might have noticed that I have my own coding style that I use, and it's been ingrained in my head for many years now, ever since I started. But your style is probably not going to be my style. It's going to be different, and that's okay. It's just like writing a paper, right? Everybody who writes a paper has their own writing style. Same thing is true for code. You're going to find your own style, your own ways of approaching problems that make you feel comfortable, and that's great. That's part of what I hope you'll discover along the way in this course, is your own personal coding style. Maybe it looks like mine, maybe not. I think my style is good, but I certainly have some bad habits. Everybody does. So don't feel bad if your code doesn't look exactly the same as the way I do things, or the way that the book does things, because that's somebody else's coding style. I don't even know whose coding style that is. Not mine. I do have one more thing that I'd like to discuss with you about this problem, but before I do that, are there any questions about what we've done so far? Yes?
I have a question. I guess I'm just kind of having trouble because the brackets that I'm using for index don't match our for I range where it says why don't we use the index brackets there?
Here you mean? Like this? Let me make sure I understand what you're saying.
Yeah.
Like this? Okay. It's a good question. Can somebody help me out here? Why am I using parentheses here and brackets here? What's the difference? What is len? Maybe let's take a step back a second and look at the bigger picture. What is len? It's a function. It's a function. So how do I call functions? Name of the function, parentheses, always parentheses, and then whatever input arguments I need to get the job done. Len is a function. I'm treating it like a function. This string, that's not a function. It's a string. And so I'm using the square brackets to index into it. It's a list, right? I'm using the square brackets to index into that list. That's the distinction between the two. Great question. Fantastic question. Not to make things too terribly confusing, but there are languages that do use parentheses for this, where this would be okay. I find that particularly confusing. I'm glad that Python does not do that, but there are languages that will do that. Great question. Any other questions I can answer? Yeah, what's up?
The immutable string thing, it seemed like concatenation violated that, but you just said this creates a new one every time, so result is deleted, returns a new result with the same name.
Well, result doesn't get deleted, so I guess that's a good question, right? I say that I'm creating a new string every time through the loop. So what happens to all those other ones that I had? That's the question, right? This is a somewhat technical answer, but it's a good thing for you to know as programmers. Anytime you create a variable in your code, anytime you want to remember something, it goes into memory. When you go to the Micro Center and you want to buy a new computer, the RAM is how much memory you have. That's how much space your programs have to remember things. And so every time you create a variable, you are taking a little chunk of that memory. And so every time we go through this loop, I'm creating a new string, which means I'm taking another little chunk of memory every time I go through this loop for each new string that I construct, which might sound really bad to you, right? Like, now I'm wasting space. I'm wasting that memory on strings that I ultimately don't even want. I just want the last one. Why am I wasting all this memory on those intermediate strings? The good news is that the computer is smart. It's going to see that you're no longer pointing at that old string anymore, and it's going to get rid of it for you. This is something that's called garbage collection. It basically means that you can create variables and you don't have to worry about cleaning up after yourself. All modern programming languages, well, I don't want to say all, the vast majority of modern programming languages will clean up after you. You don't have to worry about deleting variables when you're done with them. It just does it for you. You don't have to think about it. That wasn't always true. Back in the 70s and even the 80s, C and C++ were the dominant languages, and you did have to clean up after yourself. That's one of the reasons why people hate coding in those languages. It's very annoying to have to clean up after yourself. So yeah, most modern languages have garbage collection. I would be very surprised if you were asked to use a language that doesn't have garbage collection. And so creating a bunch of strings like this, not that big of a deal. On top of that, these strings are all very small anyway. They're very small. Each character in a string takes up 2 bytes, I want to say. And so you're looking at a very small amount of memory being used. When you think of a new computer these days, probably sold with, what, 4 gigs of RAM, 4 gigabytes of RAM or so at a minimum, maybe. The nicer ones will have 8 or 16 if you're playing super fancy video games on them or whatever. So a very small chunk of memory for a small program like this, but it does add up. Yeah?
So as far as the immutable thing goes, does that mean that you can concatenate to a string, but you can't remove from it? Like what we talked about earlier?
Concatenate to a string, but you can't remove from it. Well, so let's think about what this is really doing when I run a line of code like this, right? Result had a value. That value exists. I'm throwing that value out, and I'm saying result is really just a label, or we would call it a reference or a pointer. It's like a sign. I have a sign. On that sign is the word result, and I just pointed at whatever I want result to be. And so, the last time through the loop, I pointed my result sign at what the string was. This time through the loop, I have created a brand new string with 1 more letter on it, and I've just taken my sign, and now I'm pointing it at the new one. That's what this line of code is doing. So I haven't changed the old string, right? Because strings truly are immutable. I'm just changing what my sign is pointing at. You cannot change strings. It's now, I say that, but then we do things that feel like we're changing strings, but what you have to remember is that even if it looks like we're changing a string directly, under the hood, Python is going to create new strings for you on your behalf to make that change happen. So even if it looks like you're removing something from a string, which I don't think you could even do, like, what would that look like? Something like this, results, how would you remove something from a string? Just like set it to empty string or something? This isn't going to work, I don't think. I mean, yeah. String does not support item assignment. They're immutable. I cannot change something within a string. Not allowed. We will see lists in the future that are mutable. They can be changed. I can remove elements. I can change elements. We'll see them probably very soon in the next chapter or 2. But strings are immutable. I cannot change them. Great questions. Any other questions? Any others? I have one more question for you then. So right now, if I do something like this, what's going to happen? Is this going to work? It'll leave the capital one on there, right? Test failed. Expected this, but I got this. That's, does that bother you? I don't know, maybe it doesn't, but for some people it would bother them, right? This is still an A. I told it I wanted to take out all the A's, and you're being nitpicky about uppercase versus lowercase? Well, yeah. Computers don't even know that uppercase A and lowercase a are related. They don't care. They're just two numbers in a program as far as the computer is concerned. It's us. Humans know that uppercase and lowercase a are related, have similar meanings, right? It's us that cares about that. Well, we could write a program that takes this into account. We could write a program that removes the uppercase values as well as the lowercase ones. How? How would I do that?
After the string, you would do an OR.
After the string, I would...
Isn't it and? If string index I does not equal character.
So this line here, I've been pointed at this if statement. So how am I gonna do this? It does not equal the character. I need to be yeah, there's a function that can help us, right? There's a function that can help us. I don't know. I should have pulled this up ahead of time, but I can pull it up now real quick. It's in the textbook. This is another example. We saw this last week too with the images and the pixels, right? There's a whole set of functions available that work well with strings. And the textbook had a whole list of them. Let me just go to the table of contents. I'll get there faster. Strings. Was it string methods? There we go. That's what I'm looking for. So here's a huge list of methods, right? And I think the ones we want are right here at the bottom of the list. Upper, lower, right? Upper and lower. Okay. How can we use those to help us then? What's the trick? I can make strings uppercase or lowercase. How does that help us with our problem? How would I write that in code? Create a new string and set it to the old string lowercase. I like that idea. That wasn't the way I was thinking about approaching the problem, but I think it'll work. I think we need to be a little bit careful, though, of how we approach this, because here's another little wrinkle. What if I then also do this? I want to keep the capital D. So I can't just lowercase the whole thing, because then I would lose that capital D as well, right? So I think we need to be a little bit more careful about how we approach this problem. Anybody? Yeah, in the back. So change the letter I'm searching for to be upper or lowercase. Yeah, I like that idea. So here I'm looking to see if it doesn't match the character, right? How can I specify this a little, how can I make this a little bit more clear? What do I really need to say instead? In English, we don't need to worry about the code first. In English. If this string doesn't match this character, lowercase, and does not match the character in uppercase. It has to do both, right? If the letter from the string does not match the lowercase or the uppercase version of the character that I'm looking for, then I know I want to keep it. Does that make sense? So how do I do that? How do I make sure this character is lowercase here, right where I'm at?
Dot lower in parentheses.
Dot lower. I just call the method. And like this, right? Upper.
You have to put the string in it.
Ah, this is the same thing that we saw in the studio last Thursday, right? I have to say this. I have to say this again. Does this make sense? I'm now checking it against both the lower and uppercase versions of the character. And it has to be not equal to both of them. Should it be or? So think about what this means if it's or. If I look at this first A, right, against the capital A, I say capital A is not equal to lowercase a. That is true or false? Capital A not equal lowercase a, true or false? That's true. True or anything. I don't even need to check this now, right? True or anything is true. So I've now let that capital A sneak by. I can show you. I can show you. It didn't even get the lowercase one. Because the other condition, right? Because the other condition would work for that one. So it has to be and. That's right. But if I run this now, okay, well, this actually proves my point though. It worked. It worked the way we were talking. It didn't pass the test, but it kept the capital D and got rid of both the uppercase and the lowercase a's. This is the behavior that I was hoping for. The test just needed to be updated to reflect that we had a capital D in the original. So yes, this is a very common thing, and I bring this up because I can't remember if it's initials or the other assignment, crypto, that's coming up, where tricks like this are going to come in handy. Tricks like this are going to come in handy for you on those assignments. That's all I'm going to say about it for now. How are we doing on time? Oh, we're doing great. Any questions before I wrap up my time with you all today? Yes, what's up, Gary?
In the text, it said that Boolean and int and float were primitives. In other words, they something you can't change.
Yeah.
Is that true for a character?
Yeah, that's a fantastic question. So let me repeat it. The textbook mentioned that Booleans and ints and floats are something that we call primitives, called primitive types. The question was, is that same thing true for a character? And the answer is yes, actually. Characters are primitive types. And to help you think about why that is, primitive type is really the smallest amount of data that I can represent on a computer without, making it even smaller still. So a string, is that a primitive type? No, because I can break that down into individual characters. I can still subdivide that string into smaller pieces of data. Those characters, though, like I can't take the letter A and make it any smaller than it already is, right? It's the smallest chunk of information. A single character is the smallest chunk of text that I could possibly represent. Those are primitive types. Yeah?
Is there a character data type like there is for instances in float?
There is a character data type, yeah. Well, actually, let me think about that for a second. I don't know how Python actually represents single characters. It actually might represent them as single character strings. This is where my I teach in Java all day on campus, all day. That's what I'm used to doing. So I love Python, actually. Python's fantastic. I'm really glad I get a chance to use it here. So when I said yes to your question, I was thinking about Java. The answer is absolutely yes. There's a char data type in Java that represents a single character. I'm not sure if the same is true for Python. Python char data type, is that a thing? Let's see what the Google says. Python only has strings, yeah. Thanks for bailing me out, Google. Yeah, this is a difference between Python and other languages, though. Languages like Java, C, C#, languages like that actually have a character data type. Python does not. Great question. Any other questions? Any other questions I can answer for you all? All right, just want to remind you, please work on the studio for today. It's it's more of this kind of the same lines about sorted. We'll go through it at 8 o'clock, like we usually do. Once you get the studio finished, please take a look at the initials assignment and just do the setup part. Just get all the tools at least. If you want to keep going, of course, you're more than welcome to do so if you have time. But I would really like it if everybody would at least get the installation stuff finished today before they leave. So studio first, and then take a peek at initials, and we'll go over the studio at 8 o'clock. Enjoy your stickers.